let's finish up this journey into acids and bases. So we will call this acids and bases. (2.0). So as discussed before, just as a quick recap of what we looked at yesterday, we learned that in normal pure water, right? The high quality H2O, that it is partially ionized, right? And broken apart into some hydroxide and hydronium ions. And if we look at the concentration of H plus in normal water, we find that it's roughly 1 times 10 to the negative 7 moles in every liter of water is that stuff, okay? And then if we take the pH, which means the negative logarithm of that concentration, okay, we come up with 7. So the pH of regular water is 7, okay? And then we talked about how if you were to add acid to regular water, so you're to take something like hydrochloric acid or sulfuric acid, right, or phosphoric acid, etc., and you were to add some of this into the water, what would end up happening is you would drive the pH down, because what you would do is you would increase the concentration of H plus ions in the water, okay? So if we add this stuff into the water, any of these into the water, what you're doing is you're adding H pluses, right? The other part, the anion, okay, usually isn't super important in acid chemistry, right? It does have some effects. In some cases, it makes the acid a poison as well as its acidic qualities. But the qualities associated with an acid, which were like sourness, dissolving of metals, corrosiveness, etc., are coming from the addition of these H pluses, right? And if you remember, H plus ions are simply protons, right? Because a hydrogen atom is just a proton and an electron. So when you strip off that electron, you just ending up increasing the proton content, okay? So what ends up happening, right, is you go from this neutral amount of H plus in there to later on increasing the value. So say you've driven it up to like 1 times 10 to the negative 1, right? So 6 orders of magnitude more H pluses than in neutral water. Now you've dropped your pH to 1. So, a quite acidic environment, okay, by adding all these H pluses, right? And you just have to remember, decreasing a negative exponent is increasing the amount of something, right? So we're going from like 0.00034563637 to now just 0. It should be a 1, not a 7. To about there, right? In terms of the concentration, right? This is a much larger number than that is, all right? So just keep that in mind. Lowering pH increases acidity. Now let's go the other way, all right? So let's talk about what happens if we add base into this. And then we'll talk about what happens when we mix acids and bases together. All right, so here's our neutral water. Again, 1 times 10 to the negative 7 concentration of H plus. And remember, since we're splitting water into its 2 parts, right? There's H2O, there's the H plus. Then we're also going to have the exact same amount of OH minuses, aren't we? Right? So now let's say we take something that is classified as a base, okay? So something that's obviously a base. So we're going to go with NaOH, okay? So this is an OH on it. We start to dissolve sodium hydroxide, okay, into this water. What you do is you release OH minus ions into solution, okay? Now, if we think about the pH, right? The pH at this point is 7. pH equals 7. Why? Because we have this concentration of H pluses. And we're going to say that adding base increases pH. It makes it go higher. So if the pH number is getting larger, what that has to mean is that the amount of H pluses is getting what? Lower, right? It's going lower. So by adding base by adding hydroxide ions, somehow that's making the H plus concentration decrease. So we're going to go like to the -8, to the -9, and maybe eventually to something like the -14. Okay? So why is that happening? Well, what's happening is the H pluses that were here are actually getting bonded or bonding or being forced to bond, and we're not going to get into equilibrium, but they're being forced to bond with OH and actually getting pulled back into being water molecules. Okay? So what that's doing is essentially it's vacuuming up, if you want, the H pluses that were naturally there. So adding OH decreases H plus by forcing it to turn back into water. So if I have an H plus floating around there, if I have that proton floating around, and I put a hydroxide near it, well, it gets instantly attracted to it and forms back into a normal water molecule. All right? So adding base decreases the H plus. Okay? So looking strictly at the pHs here, okay, if we look at the pH, by adding base, we drive this value down, and the corresponding pH value goes up, 8, 9, in this case up to 14. All right. So that's kind of the principle behind how acids and bases work together. All right. They are essentially two sides of a coin, and that coin is water. One side is the positive side, the protons, the H pluses, and the other side is the negative, the OHs. All right, the hydroxides. So now what we'll talk about is the concept of neutralization. Okay. So you've probably heard of this before. Acid-base neutralization, or for short, just a neutralization reaction, or an acid-base reaction. And we'll draw one out here. Let's say that we have some aqueous HCl. What does aqueous mean again? Dissolved in water, right? So that's what we're starting with. Let's draw it. So here it is. It's like a little bottle right here. Okay. We know that there's HCl added to here. Okay, and we'll say that the pH of this is like 2. Okay, the pH of this is like 2. So we took water, we added hydrochloric acid to it, pH is like 2. So now what we're going to do is we're going to start to add in another solution that we've made of NaOH. And let's say the pH of this is something like 12. Okay, very basic, right? 12. So we're going to mix these together. We're going to add NaOH. So what's going to happen here? Well, you have essentially a lot of H plus ions floating around in here, right? You're nowhere near neutral. You're at like 1 × 10 to the -2 in terms of the concentration of that. So that's H pluses per liter, or I should say moles of H plus per liter. Okay, and now we're going to add in NaOH. So we're going to add in something that has a high concentration of OH minuses in it, right? Does that make sense? All right, so if we do that, well, when these come into the solution, they're going to pair off with the H pluses and turn back into what? Yeah, we've got H pluses floating around. You're going to add some of these in, and you're going to turn those back into waters. So every time an H plus gets turned back into water, this number gets larger, right? We decrease the amount of H pluses that are in there. So our pH drops to 3, then 2, then 1. Oh, I'm sorry. Our pH climbs to 2 to 3 to 4 to 5 to 6 and eventually to 7, which is where we're going to stop, right? When we stop, when we get to 7, we say we've neutralized the acid. We've brought it back to the pH of water. So let's see how that might work. So here's HCl. Remember, it's aqueous. So in reality, we're talking about ions dissolved and able to float around, right? And then we're going to add to that aqueous NaOH. Okay, so now if you saw this, you would say, okay, this looks to me like it's going to be a double displacement, and it is, but it's a special kind of double displacement where the water, or the H plus and the OH minus, come back together to form water, HOH, which we draw as H2O, okay, and then you end up with NaCl, an ionic compound, okay. That should be balanced, and we should be good. You just have to remember, water's a liquid, and this will end up just being aqueous, right? If we add just the right amount of NaOH, you will exactly scoop up all the H pluses such that the overall pH goes back to being 7, okay? So let's do one more example. I won't be do it in quite so much detail. Let's say you have something like this, H2SO4, so some sulfuric acid in solution, and we can neutralize this with, we'll use sodium hydroxide again, NaOH, okay. So if you see this, right, you're going to recognize that this is an acid. Why? Because it's an ionic compound that has H as the cation, as the positive ion, right? This is a sulfate ion over here. You can find that on your table of common ions. Since it ends in 8, we say this is sulfuric acid, okay? Bases, you got to recognize by the fact that they have an OH on the back, okay? So there's that hydroxide ion back there. And, you know, you just have your sodium metal here. So the anion is OH. Will all bases have an anion that's OH? No, they won't. However, they will do something that increases the OH value of water. And I can show you a separate example of that, and that's ammonia, why it becomes a base. Okay, I'll show you that in a minute. But anyway, you mix these two things together, okay, and you're going to end up with some Na2SO4, so sodium sulfate, and water. Okay, now is that balanced? If we want to balance this, we've got to put a 2 in front of here first. Okay, now let's just see. And I think we got to put a 2 here. Now we should be balanced. Yeah, okay, so there we go. So there's an acid-base reaction, right? So let's just go general. The general form of an acid-base reaction, general form, is just this. It's HX, okay, so that's H representing the H ion, and then X, it's attached to something, sulfate, acetate, fluoride, chloride, etc., right? Plus, we'll say Y, OH, right? There's some OH involved there. And you get XY plus water. All right? So acid, in words, plus base gives you, I'm just going to call this a salt and water. Okay, so when I say a salt, I just mean any ionic compound, any normal ionic compound. Okay, and that's it. All right. So I mean, there's a lot of kind of background there, but it's not incredibly difficult to understand. This is just kind of an introduction to it. Next year in chemistry, you'll put numbers on all of this stuff. Well, more numbers on it, and you'll be able to like calculate, say, how much base you'll need to neutralize a certain amount of acid and so on. But for now, that's all we really need to cover. And essentially at this point, once you can recognize the concept of pH, why low pH makes an acid, why high pH makes a base, and recognize acid-base neutralizations, we're essentially as far as we need to go with chemistry. Okay, so we'll wrap her up with that. Don't